Hi everyone, today we are going to talk about law of cosines. So just want to remind you guys that we've been working a lot with right triangles, and we have a lot of options for solving different right triangles. So we can use the Pythagorean theorem, the special right triangles, or our trigonometric ratios, which was that SOHCAHTOA. However, you need to remember that if our triangle is not a right triangle, we cannot use any of those methods. So for non-right triangles, we have two options in terms of trigonometry. We have the law of sines and the law of cosines. So today we're just going to focus on the law of cosines. So the law of cosines states in triangle ABC, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. These three statements are true. Now, they look really scary, but if you look for a pattern, it's not as bad. So this is saying that A squared equals B squared plus C squared minus 2 times B times C times cosine of A. So the pattern that you'll see with these two is on the left side of the equation, that's going to be one side squared. Then you're going to add up the other two. So if we're working with A, it's B and C. If we're working with B, it's A and C. And if we're working with C squared, it's A and B squared. And then you subtract 2 times those same two sides. So here AC, here AC, here AB, here's AB. And then we multiply that by the cosine of whatever angle matches the side on your left. So here it's A squared, we're using cosine of A. Here's it B squared, cosine of B. Here it's C squared, and it's cosine of C. So don't be too overwhelmed. There is a pattern here. And once you know the formulas, it's just plugging in the values and solving. So there's 2 times when we will use law of cosines. And case 1 is when we are given side, angle, side. So 2 sides with an included angle. Or when we are just given 3 sides. So let's look at this first example. Here they say that triangle ABC. So let's draw our triangle, and let's make sure we label our points and sides accordingly. So it says find A, so that side A is across from angle A. So I'm going to call it X. If side C is 8, side B is 10, and angle A is 60. So you can see here that we have a side, an angle, and then a side. So this is a perfect time to use the law of cosines. So we are finding essentially A squared. So how we set this up, we'll say, how about instead of calling it X, let's actually call it A. Let's say A squared equals, so remember you take the other two sides and square them and add them up. So 8 squared plus 10 squared, and then you do 2 times the other two sides, 8 times 10, and then you are going to multiply that by the cosine of whichever angle matches your side you're trying to find. So the cosine of 60 degrees. So first thing we're going to do is we're going to start simplifying this side of our equation. So we have A squared equals 64 plus 100. This we can pause and plug into our calculator, and we'll actually get minus 80. If you plug 2 times 8 times 10 times the cosine of 60 into your calculator, you get 80. And then from here we can keep simplifying, and we'll get A squared equals 84. And remember, the way that we undo a square is by taking the square root. So here we have 2 options. We can find a decimal approximation, or we can simplify it and keep it as a radical. So let's try simplifying the radical. So let's start our factor tree. Here we could do 2 times 42, which will be 2 times 21, which will be 3 times 7. So you can see that I have a pair of 2's. So we can say A is equal to 2 times the square root of 3 times 7, which is 21. Or you can plug this into your calculator and get a decimal approximation for the square root of 84. and we get approximately 9.2 if we round to the nearest tenth. So this will just depend on what you're asked to do. Are you asked to write it as an exact answer or as a decimal approximation? Okay, so go ahead and pause the video and give this problem a try. Okay, let's check our work. So here, given the information, you can see that we have a side angle side scenario, which is a perfect case for law of cosines. So we can say d squared equals 28 squared plus 19 squared minus 2 times 28 times 19 times the cosine of the angle that matches, 49 degrees. This you can actually plug into your calculator exactly as you see it. 28 squared plus 19 squared minus 2 times 28 times 19 times the cosine of 49. Your calculator can handle that. And then you should end up with, I rounded it, 447.0. And then you can take the square root of that and get a decimal approximation as well. So once you start rounding here, we'll just want to use a decimal approximation for the rest. Okay, one more example together. Let's start by drawing our triangle. So here we have triangle QRS, and they would like us to find angle R, so I'll call it theta. If side R is 23, side Q is 37, and side S is 18. So we're going to want to work with this because we're trying to find this angle, so we'll start with this side. And notice that this is a side, side, side scenario. So here, like I said, we're going to work with this side. We can say 23 squared equals the other two sides squared. So 18 squared plus 37 squared minus 2 times 18 times 37. Let me zoom out. Times the cosine of theta. So our goal in solving right now is to isolate cosine of theta. So without even simplifying anything, I'll do this in my calculator later. I can actually just move both of these things to the other side. So I can actually write it, I'll keep it as 23 squared because that's going to be a large number. And I'm going to subtract 18 squared. And I'm also going to subtract 37 squared. So it's essentially we move this term to the other side and we move this term to the other side. And then I'm going to multiply 2 times 18 times 37. And we get, so we'd have negative, because it's negative 2, 1,332 times the cosine of theta. And now we can simplify what we see here, and you can just plug that in exactly how you see it to your calculator. 23 squared minus 18 squared minus 37 squared, and you should get negative 1,164 equals the same thing on the right. And then we're going to divide both sides by negative 1,332. And we will get, a decimal approximation for that, and that's okay. So we'll get 0.87, so I rounded to the hundredths here, equals the cosine of theta. And now, since I'm trying to find the angle, remember I swap the two values and then I use arc cosine. So remember, we're going to do that anytime we're trying to find the angle. And then in your calculator, you can plug in cosine of arc cosine, of 0.87 to get a decimal approximation. And we should get approximately 29.5 degrees. So try to make your job a little bit easier. For example, when you're trying to isolate cosine of theta, don't multiply these out yet because those are going to be large numbers. So you can actually move them over and then plug this into your calculator. Just makes it a little bit easier. Okay, go ahead and pause the video and give this last problem a try. Okay, here we go. So here we're trying to find this angle, so we're going to use this side as this the left side value of our formula. So 30 squared equals 24 squared plus 18 squared minus 2 times 18 times 24 times the cosine of theta. These I both subtracted to the other side before I simplified. Now 30 squared minus 24 squared minus 18 squared is actually 0. It's okay to have 0 in your equation. I'm still trying to isolate cosine of theta. Remember, that's our goal, is to isolate cosine of theta. So then I can divide both sides by negative 864, still 0. And then to find the angle, I'm going to swap the values and use arc cosine. And it turns out that the arc cosine of 0 is 90 degrees. All right, that is all for today. Thank you so much for watching.